I hope you had a nice lunch. I hope you're not too sleepy. So, because we're going to look into a very interesting topic of the release upgrades. So, I hope you're ready. So, let me introduce myself first. My name is, Luís Rascão. It's a hard Portuguese name to pronounce. I've been working at Miniclip and at the same time doing Erlang since 2014, loving every minute of it. Don't want to go back again to old times. So yes, Miniclip. Let me introduce you the company. It started out as a mostly Flash games company on browsers on the web, then pivoted to mobile. We have some pretty big hits in the stores. 8-Ball Pool being the largest, then Agari and Soccer Stars also. So I work as was mentioned, I'm the tech lead of the 8-Ball Pool server. So you definitely check out these titles. I'm sure you'll enjoy them, or your kids will, most likely. So, 8-Ball Pool is our biggest hit. We have around, it's a pretty big game, it's around 18 million DAUs, daily active users, unique. We have had peaks of 750k across several versions. And just for the game servers, we have large cluster, largest of 26 machines, a lot others to support other infrastructure related social and whatnot, and it's mostly Erlang. So, bugs. I like this quote. The guys in client showed me once, I like it. So debugging is like being the detective in a crime movie where you are also the murderer. So yes, I guess that rings true and we feel it. Bugs are a fact of life. You can't really escape them. If you're writing software, you write bugs. That's inevitable. If you don't have bugs, it's because you're not really writing software. So let me tell you this story an amusing story on 8-Ball Pool. You had once. So 8-Ball Pool, this is the main screen where you can scroll across tiers to play in. Higher tiers, you have to stake higher amount of coins to enter. And there's that little line saying the number of online players on that tier. So basically, when you log in, you get from the server the numbers of players that are playing and show it to the client. If you get paired with someone on that tier, it increments. You leave the game, it decrements. So we had this on one release. We had this merge gone bad. So we had basically a leak on the number of online players per tier. So it kept increasing and increasing. So we found that quick enough and fixed it, and the leak was gone, but still we had an issue because the values were still large. So production talked to me and said, hey, can you do something about this? So yes, I went to the live servers, I eyeballed more or less the values, and I set the new tier values. So that was fine, and it was like in the afternoon, all day was running smoothly, until around 10 or 11 at night, PagerDuty calls saying something's broken, it's your fault. So I go on the live and everybody was getting kicked out. Everybody. It was the biggest drop I've ever seen, fastest drop as well. So I went on live and quickly found the issue. So what I did when I set those made up values on the tiers, I set them slightly lower than what they should be at the time. So as night progresses and people go to sleep and do other things, the number of concurrent plays starts to drop, and eventually it dropped below 0. So what had happened then was negative values were being sent to the client. We're using protobuf to encode that number, which was unfortunately an unsigned integer. So it was crashing all connections and nobody could get in. So right, even it's unexpected. Bugs happen, you can't really prevent them, but you can do something about them. What can you do? So the easiest approach, the simplest one, go in, stop the servers, fix the thing, start them back up, but downtime. Nobody likes downtime, right? Banker Cat doesn't. Another choice, you have the blue-green deployments are also quite useful. So you have a load balancer, you keep two stacks, blue and green, identical. So you have an issue, direct traffic to the other stack. Make sure that everything is running as expected. And that's it. So if you have persistent connections, as we have in pool, you have to wait for clients to eventually end up their games and their sessions and go to the stack with the fix. And so you probably want to automate this or have someone else do it for you. But OTP gives us this nice way of updating the running code without stopping anything. So for simpler fixes, of course, it depends on your use case on the fix itself. But some cases might be simpler just to go and patch the servers. So these guys are doing. So the dumbest, simplest approach: you go, make the fix, build the Beam file with your fix, go on live, overwrite the one that has the bug, attach to the console, just do load, that's it. You're done. But it gets messy if you do this a lot of times. So if you're applying a patch that it's more than one module, you better be sure of the order in which you load them by, because it might run in some nastiness. So your app on live says it's running some version, but as you patch individual modules and you don't do anything else, that's not going to hold anymore, and you can get up to a point where you don't really know what version you're running. You have to be disciplined about it. Also, if you do changes on your sysconfig file, you better do them on the console and update the file first, because machines come and go. You want the changes to be persistent and not have regressions. But it's not all bad with this approach. So you get to apply your changes one at a time and see how it works out and make sure that there's no regressions or issues. So we have to keep in mind that bug fixes can have bugs themselves. And most of the times they're even worse than the original ones, because you're doing them in a rush. You're cutting corners, trying to get things done fast. So on the topic of hot code loading, so the simplest explanation is, and the naivest from my point of view, is just per module, 2 code pointers are being held. It's the current pointer and the old one. So when you load a new version of that module, what happens is the current points to the new code and the old keeps pointing to the old code. And any qualified function call you make will go to the current one. As you know, the gen server, all of the gen star behaviors have a lot of logic inside the loops and whatnot, and they give you this for free. You have to keep in mind, for example, if your process is blocking on something that is not going to make a fully qualified function call, you might not see the changes. So you're blocked on an accept, for example, you do the code load, and the changes seem to not be taking effect. This is because of this this feature. So the load call. If you look at OTP code, you'll see the layout of the call is simply do a code purge of the module and then load it. So code purge by default is a brutal purge. You also have the soft purge. There's some changes in OTP 20 regarding this. I have to look into them a bit deeper, but yes. So this is up until 19, I believe, or 18. Purging, you have the soft and the brutal purge. So the soft checks all processes running. If any of them are running old code, it makes this call, the Erlang check process code. It will simply fail the call and not go through. The brutal one, it's brutal as its name implies, and it checks and kills anything that runs old code. So you might get a killed process doing second load of the same module. Another something more or less related is the stickiness of the directories. So you can stick and unstick directories on the search path, and basically the code load file will fail. This is how lists, for example, the OTP paths are declared as sticky to prevent you from doing load of other the built-in modules. I heard somewhere that it was related to people creating their own lists module, so they wanted to prevent this. So the release upgrades, there's a structured way of changing code, of doing the same task, but a bit more of a structured way. So you have the gen star code change, methods. It allows you to start new applications. It reloads the sysconfig file of the new version and informs the applications of what was changed in those config files, and also upgrades and downgrades of applications. Downsides of it, they're really complicated. So, and on Fred's book, Learning Some Erlang, there's a picture in there describing it as the ninth circle of Erlang. And yes, so it does a walkthrough. Most people skip it. It's pretty complicated. So the workflow on that, it begins by you writing an app-up file, an application upgrade file. So this application upgrade file is then translated to a release upgrade file, which is kind of the lower level version of the application upgrade. And then with that, with the release upgrade and new code, you can apply the upgrade on a running instance and have that running new. So the basic structure of an application upgrade file. So it contains sets of instructions that allow you to define how the application can be upgraded and downgraded if you might want to do downgrades or rollbacks. So it's a single term of this format, and basically the VSN keeps a version, the current version more or less. And if you want to upgrade from version, those are the instructions you apply. If you want to downgrade to that version, those are the other instructions you apply. So this is an example from an upgrade from 1.9 to 2.0. On the application upgrade, you have a lot of instructions that you can specify. You have the load module that allows you to load a module into the VM. It takes the module, the pre-purge and post-purge strategy. I mentioned those two types of purge strategies. These are applied before and after the load. And also a list of dependency modules. This allows you to you inform the VM in what order do you want to load the modules. And then you have add and delete module that both take dependencies as well, and the add, remove, and restart application. The update. You have the update, which is a special method that allows you to synchronously update processes running that module. So it's applied to GenStar processes. So it basically obtains the supervised processes that are running this module, and then it waits for them, asks them to suspend themselves, and then have them call the code change callback that a lot of people don't implement because they don't use the release upgrades. So the code change callback takes the old version, the state of the current really running version, an extra argument, which is custom data that you want to pass through your callback, and then the result, you return a new state, which is the migrated state. So the extra argument is data that comes directly from the application upgrade file. So the update here is the module, the timeout, a change, a soft advanced extra. So you see here the advanced extra on the change. The extra term is where you pass the custom arguments you want to see being called on the code change, and then as well pre-purge, post-purge, and dependency modules. Also the configuration changes that it gives you. So after the upgrade, the application controller will compare the new configurations, the old and the new parameters, and it will invoke your callback on the supposedly the topmost application file. It invokes the config change callback. It gives you the change entries, the new ones, and the ones that were removed, so you can tailor specific behavior to act on these. So if you want to do it by hand, this is the short version, very short version. You write the app file, you give it to systools, and systools gives you the make relup and make tar commands, and then you take this result, you go to the node, and then you can call release handler methods to unpack the release, check which releases are running, install the release, and make it permanent. You can choose not to make it permanent, which means if you start the node, it will still run the old version before it's set permanent. So on the subject of automation, there are some efforts to try to ease the burden of the developer on this on these issues. So there are already some plugins that take away some of this manual labor that you have to go through. So there's Relup, Relflow, and this other one, which is the one I wrote, which is Rebar Free AppUp plugin. So I'll be telling you about a bit of the features that it gives you. So at a glance, it gives you AppUp generation. It generates the application upgrade for you. It takes care of the module dependencies of the release you want to upgrade. It validates and compiles an AppUp source file, an optional file that you can specify, and it does the also migration of the state records automatically, or it tends to. So in terms of AppUp generation, you simply have to generate 2 release versions, which is the one you're on live supposedly right now, and the one you want to go to, the one you want to upgrade to. So you tell the plugin to generate the application upgrade file. So it does this. It checks out the 2 releases, finds out what was changed, and generates the instructions necessary to bring one version to the other. So it takes care of all the adding, the loading, upgrading modules. It also checks for changes in supervisor specs and generates the instructions needed to stop the children of that supervisor. The module dependencies are part of it are determined using Crossref. So it basically knows which modules are changed. So it uses Crossref to find the invocations of each of those modules, intersects them with what was changed, and just gives this list to the in the application upgrade for the VM to take care of. So basically, just need to tell which dependencies exist for each module. So if you can't really support dynamic calls, if you build atoms with module and name, invoke them manually, there's no way to plug in to see this. So it's just static calls. It also validates an AppUp source file, so you can always generate your AppUp file and go with that. But sometimes you want to put some finer grained instruction on your AppUp file, so you want to put it in source control. So you do it the same way as you do your app source file. You create an appup.source file, you put it along your source code. So when you say compile, it will check it, validate it, template, and evaluate it. So the templating, you have some built-in variables, mustache variables that you can put in your AppUp source file. And right now it's just the VSN, which is the current version of the release. It's evaluated also, so it's run as if it were an Xscript file, and it has one state variable, one state built-in variable that you can use, which is the rebar free state. And then you can call from methods from both your release and rebar freeze to obtain information from this state, if you so wish. And at the end, it validates and ensures that there's a valid AppUp format that it produces. So this is a simple example. So it uses the state variable, and it fetches information regarding the Relup application, and then it extracts the version, which it ensures that it matches the current version being templated, and then generates the final term, which is the AppUp term. So you can see you can actually specify regular expressions on the matching of the versions. So here, no matter where I upgrade to or downgrade, upgrade from or downgrade to, I always restart this application. So state migration. This is a tricky one. So most of the gen servers, the ones I use and a lot of people use, keep state and usually do that through a record. So there are changes where your fix needs to change the record structure, but it's going to be tricky doing that because, as you know, tuples are records are just tuples in Erlang. So if you, for example, do it, add another field to the middle of the record, or yeah, that's the trickiest one. You have some choices for it. You can do it manually. You can, on the code change, you get the previous state, extract all the values, and then by hand set all the elements of the new record. You can use this nice project of Wolf embedded in the parse transform project. There's sprex. It's a parse transform that you can declare on your file. It will basically generate a bunch of methods for every record defined in there, getter, setter, whatnot. And there's this interesting one which is convert, which lets you convert from one record to another. You have to define the two, and it just converts the two. And the final choice is using the plugins code ejection facility. So how does it do it? So upon your request, so you need to specify, tell the plugin which record holds your state. So it will inject code directly into the code change method. So to do this manual thing you would normally do, but it does this automatically. So it converts between two records. So upon this request, the plugin will get the old abstract code of the new version bin, get the record definitions as well on the current and previous versions. It will inject a call directly into your code change invocation that just converts from one record to the other. There are some caveats to this, of course. If you remove records, if you rename records, it's as if they were removed. But it essentially tries just to map out the previous and the current values, and then just overwrite the final beam file. So when the release upgrade occurs and the code change gets called, what you get from the argument is no longer the old state, it's now the new state, because the injection call did that migration for you. So you can still access the old state, it's kept in the extra argument, it's added as a tuple, so it assumes that it's a list. So yeah, let's see a bit of this working. So right now I use this Relup 1 project. It's a very simple one, and it's running 1011 version. So you see 1011, and it's a very simple project. It has one supervisor, and right now it has 2 children. And we're looking at Relups serve 2, get its state. So it has just a state record with an ID element, which is 0 right now. So let's change it, why not? So let's change it to 42. Okay. So that's our system, it's running. So I'll go just through the workflow generating the actual Relup. So right now we are on 1011, which is the same version we're live. And we'll just build our release then, which is the source release. So we build that, we go now to our target release, which is just the next one, might be some other. And let's look what I did in that one. So what I did simply was, on the ID, added two new fields to our state record, which is name and description. They're binaries and initialized to empty binaries. And here on the code change method, what is simply being done is extracting attributes and just printing them out in this IO format change, code change. All right. So we're now on 1012. I'll generate that release. So now we have 2 releases, so there's no ambiguity on which one I want to generate the application upgrade. So I'll just ask to generate it. So you see it generated one application upgrade from 1011 to 1012. Let's take a look at that. So the application to upgrade from 1011 to 1012, I need to update this module. This is the advanced instruction telling it it's a gen star process that needs to be code changed. And this is the strategies that are default, which is purge, pre and post. If I wanted to downgrade from 1011 from 1012, I would run the exact same instructions because nothing else changed beside the code. So I'll just generate a relup, generate a tar file. So you see here, hitting this line here, if you can see it, yes. Injected code for state record migration of process Relups server 2 from 1011 to 1012. This is the code change injection thing. So I'll just deploy that. So I'll move the upgrade tarball to my live installation, so to speak, and I'll apply it. So right now the versions that are running, I can just call this and I see 1011 is running and it's permanent. So what I want to do is upgrade to 1012. And now I'll check that. So we have 1012, which is set as permanent, which is the default, and 1011, which is marked as old. I could still roll back to it if I wanted. So the code change I got. So you see the code change from this number, which is the hash of the beam file, the previous one, it's changed from this one to the next. And as you can see, it should be printing out the old version, old state record, but it's not really because it's been changed already. So it was the old record was extracted of all its values, the new record was instantiated and then set with the old values. So from now you have the new state, and then you can check the version. So it's running 1012. There's really no ambiguity here. And the state is now this. So let me show you this other use case. So I'll go to 1019. One zero 19 is more or less the same structure. We have, we have two children of this supervisor, SRV2 and SRV. And now let's go through the AppUp workflow. So we'll just check out 1019. And I have to do something first because on this one version behind, or two versions behind, I created an AppUp source file. So for the purpose of the demo, I don't really want to use that. So I'll delete it. So it doesn't get picked up. I want to use the one that gets generated in here. So I'll just generate this release. Go to 1020. Which is one I want to end up in. And let me show you what it does. So 1020, add new Relup SRV3 supervised gen server. So what this needs basically is just adding a new gen server to the supervisor. And this new gen server, it's basically simple, it doesn't do anything else. Just adds. So let's go through the release. So we generate 1020, generate the AppUp file. Shit, sorry. I have 4 versions now. So let's see if I can get out of this one. So I have to tell it which one does it need to upgrade from and to. I think it's from 1019 from version. Maybe dash. Ah, yes, sorry. So demos, right? Okay. There's always the easy way, starting from 0. Okay, generate 1019. Generate 1020. Okay. So 1019, 1020. So this is the application upgrade it needs. So to upgrade from 1019 to 1020, you need to add the Relup SRV free module. You need to update the supervisor because the spec has changed, of course. And then you need to apply this method, which is just restarting the child of the supervisor. To downgrade, you need to do the inverse calls. So you need to terminate the child, you need to delete it from the supervisor, then you update the spec, and then you delete the module. So it's the inverse calls. So you generate this Relup 1020, so I have 1019 running, yes. I see someone's playing it pool already, nice. Can mistake that sound. Sorry, forgot the tar. Generate the tar. Let's deploy it. And to 1019, yes. Let me move to it. Now, same drill, versions. Okay, let's upgrade it 1020. Okay, so it's upgraded to 1020. Let's see. So something happened here. The Relup supervisor said it started the Relup SR free gen server, so we'll get it, and it's actually running. So yeah, we have some more other interesting commands that you can run in here, besides checking versions. Say we're done checking that this version is okay, it's running as expected, so you can just uninstall it from the system. So you say install of the old version. And it's gone. So yeah, this is basically what I have. Thanks.
All right, so we have a few minutes for 1 or 2 questions. Hold it really close.
Hi, I have a question about the dependent application upgrade. Where find the dependent modules upgrade?
You mean the module dependencies? How
Yes.
are they generated specifically, or
Application. I mean, my main application depends on some other applications, and I want to upgrade dependent applications.
Okay, so I guess this would be the order upon which the application upgrade files are applied to your system. You generate one application upgrade file per application. So when you say the relup file, the release handler, this is actually the way the thing gets ordered in the release upgrade final result. I don't have a really good answer for that because I never encountered the need to upgrade a lot of applications which are interdependent. I've done upgrades which are not dependent. I've never really had the need to enforce one order before the other. So yes, I can't really answer that, but it's something I'll look for sure.
Anyone else? Yep.
Hello. So it's regarding the module dependencies you discover with Xref. What rules do you derive from the call graph?
So it's a very simple approach actually. It just takes for a module, it just gets Xref to spit out all the dependencies, all the modules that it uses. And then it simply intersects that with what you have to upgrade. So if you have 3 modules to upgrade, and then it just uses that for intersection with what each module has to say, the modules it uses. And then it simply gives this to declares this list as dependencies. So actually the release handler is really doing the hard work here, which is connecting all, doing the graph and then ensuring what gets applied in which order. So this list is just what is being used, and then release handler does the rest.
So if module A calls a function in module B, then module A is dependent on B, or what do you mean?
So yes, yes, so on the application, the load module, you would see on the list of the module A, you would see module B there. So you just keep that way. You're informing release handler that it needs to load module B first, but you're just stating the list of dependencies. You're not, the release handler ensures that the order in which they are applied.
Okay, I think it's a very simplistic approach.
It is.
I spent some time trying to figure out how to load modules in a safe order, and yeah, actually I had to put on a lot more rules than simply one.
Okay, let's talk after.
Thanks.
All right, we are out of time, so please thank our speaker.